Good day and welcome to recording 1A in a series on solving rational equations for Unit 6, Chapter 6, Mathematics 2200. We'll focus on using lowest common denominators to simplify and solve rational equations. Let's look at this example. Solve 4y minus 1 over y plus 2 minus y plus 1 over y minus 2 equals y squared minus 4y plus 24. First thing we do here is factor any denominators that we can factor. So the only one we can factor is this one. So we have 4y minus 1 over y plus 2 minus y plus 1 over y minus 2 equals y squared minus 4y plus 24 over y minus 2y plus 2. That tells us that since y minus 2 and y plus 2 occur no more than once in any of the denominators, our LCD is indeed y minus 2, y plus 2. That in turn tells us what the non-permissible values are. Y equals 2 and y equals negative 2 if we set those two factors equal to 0. So now from here, two methods of solving a rational equation are going to be demonstrated. You should be able to use at least one of them. You don't need to use both, but you should be able to use one. In this first method, we multiply all the terms by the LCD and simplify. Now this method takes a little bit of space initially, but basically each term here gets multiplied by y minus 2, y plus 2 in this case, because that's our LCD. Like so. And I have y plus 2, y minus 2 over here. Now what that allows me to do is to divide off the like factors, simplify in each case. So I'll simplify here, here, and here. So right here I have a factor of y plus 2 can divide into this one to give me 1, leaving me with 4y minus 1 times y minus 2. And then here I've got y minus 2 can divide off, leaving me with subtract y plus 1 times y plus 2 equals, over here, both my y plus 2 divide off and my y minus 2's divide off. So all I've got left is the numerator that I've got there, y squared minus 4y plus 24. A little bit of FOIL work gives me 4y squared minus 9y plus 2 for this first expansion. Subtract. Now I'm going to have to be careful there because I do have a subtract. And when I expand this, I will have to subtract that expansion. I get y squared plus 3y plus 2 equals y squared minus 4y plus 24. Now I'm subtracting here, so I really have to add a negative, or in which case I'd have to distribute that negative anyway, so let's do it right away. We've got 4y squared minus 9y plus 2 minus y squared plus 3y, or minus 3y rather, minus 2 equals y squared minus 4y plus 24. It's a quadratic equation. We want to make it equal to 0. I won't show all the rearranging, but essentially it works out to 2y squared minus 8y minus 24 equals 0. I think I can solve this one by factoring. Take out a 2 first of all. And I have 2 outside of y minus 6 y plus 2 equals 0. So that's going to give us y equals 6 or y equals negative 2. But recall from this slide, -2 is a non-permissible value. Therefore, y equals -2 is extraneous because it's non-permissible. And y equals 6 is our only solution. Method 2 looks a little different at this stage. We simply write each one of our rational expressions with the LCD. So this one is missing the y minus 2. And what I do to the bottom, I got to do to the top. This one's missing the y plus 2. So I multiply by y plus 2 in the top and the bottom. And then over here, I already have the LCD. Once I have the LCD, all I need to do is compare the numerators. So I can eliminate the denominators altogether. The only way these fractions can be equal, if they have the same denominator, is if they have equal numerators. So we've got 4y outside of. All right, turn that blue. 4y times y minus 2 minus y plus 1, y plus 2 equals y squared minus 4y plus 24. So if you go back and look at method 1, that's the exact same equation we got back there, so I won't bother to resolve it here. You can look back there. The main thing is, how do we get rid of the denominators here? In conclusion, to solve a rational equation, factor all denominators, identify the LCD, find non-permissible values, choose one of the two methods presented, solve the resulting equation, and then check solutions against non-permissible values to see if there are any extraneous roots.